Okay, so today we're just going to kind of wrap up that activity that we did, talk about these properties, why do we need to know those properties, and one other formula that maybe you remember from last year is the change of base formula. And again, this is leading us to solving equations algebraically with logarithms and exponential functions. So the posters that you made should have been leading us to these three basic properties, and I wrote them again in terms of log base A or ln. But if you remember your exponential rules, then logarithms have the same kind of rules here. Remember that when you multiply exponents with the same base, so number one here, I'm going to just kind of show you like where this comes from. So number one, if you have a, so I'm going to write that as x. If you have x to the a times x to the b, well, remember that you add those exponents, x to the a plus b. My b's are looking like d's. Well, remember that a logarithm is just an exponent, and hopefully on the properties that you came up with yesterday, you realize that if you had the multiplication of two numbers here in one logarithm, you can break that up as addition. So that's the same as log base a of u plus log base a of v. So multiplication goes to addition. And the same thing works with ln. So ln is just a special logarithm, so we can say ln of u plus ln of v. Or the other way works too. If it's addition, you can put it back as multiplication. Remember that when you divide exponents, so number two, if you have x to the a divided by x to the b with the same base, remember that you can subtract those. So that's x to the a minus b. So in logarithms, which is just an exponent, if you divide inside a logarithm, you can always break that up as subtraction. So you can say log a of u minus log base a of b. And ln of u minus ln of v. And then the last property, I'm kind of running out of room up here, but remember if you have like a to the x to the y, if you have a power to a power, that's just multiplication. So that's a to the x times y. That's times y. Well, that's what this last one is. Basically, when you have u to the n, or the logarithm is an exponent and the n is an exponent, you can pull that n out front. And this is what's probably the most important rule when we're solving equations here. And so we can pull this n out front, and we can write that as n times the log base a of u, or we can say n times the ln of u. All right, you need to know those properties. Today we're not going to really do anything except for practice using them, but then that's going to lead us. The next section in this chapter is solving equations using these properties and all the other properties that we've learned so far in this chapter. But today we're just going to practice going from one form to the other. So these first ones here, expand each logarithm. That means break up the multiplication as addition, the division as subtraction, and then number 3 there, I have a few things in there just to kind of make you think a little bit. But when you see this today, expand means break it up. So when I see division, I know I can write that as subtraction. You have to write log every time. So we're going to write that as log 3 of x, and the division makes it minus log 3 of 9. Then you want to look at it and say, can I do anything else? Now that I broke it up, well, I can't do anything with log 3 of x because that's just x. I don't know what x is, but I can simplify this one. And they're not all going to work this way. But this one we can simplify because remember, that's like saying 3 to the what power equals 9. So log 3 of 9 is really just 2. So I can say log 3 of x minus 2. Same thing over here. Now only this one's multiplication. Multiplication breaks up as addition, so I can say ln of x plus ln of e to the x. And we could go one step further here and kind of prove that property I gave you the other day about ln of e to the x and what it cancels out to. Remember that if you have an exponent up here, you can pull it out front. So that's the same as saying x ln of e. So that property that I gave you last week that says ln of e to the x equals 1, this is kind of a proof of that. So ln of e is just 1, so I just get ln of x plus x. Be really careful here and don't say that that's ln of 2x, right? There's a difference between ln of x plus x like this in parentheses, where you could add those x's together, and this is ln of x's together and then plus x. So really important if you're adding or subtracting something in a logarithm that you put it in parentheses, because if it's not, then it's not with that ln. So again, just kind of be careful as you're doing these. And then you get something like number 3, which is kind of a big mess. I'm going to do it in a few steps. And again, the more you practice these, the better you get. But step 1 is I'm going to break that division up as subtraction. So I'm going to say the cube root of x squared plus 1, and then division becomes subtraction. Don't forget to rewrite the log every time. And then I'm going to say parentheses x squared minus 1. And you might think, well, I'm done. But remember that we can simplify exponents. And so the cube root can be written as an exponent. And you want to always look for that, especially with logarithms. So you could rewrite this as log base 5 of x squared plus 1 to the 1/3 power. And remember, I could pull that 1/3 out front. So I could say 1/3 times log base 5 of x squared plus 1. And again, I have to put that in parentheses to show that the 1 is with the log. But anytime you have an exponent, you want to pull it out front if you're trying to expand it. And then this one, again, a little bit tricky, but think about this. Could you factor x squared minus 1? Oh, yes, I could factor that into x minus 1 times x plus 1. Why would I want to do that? Well, multiplication breaks up as addition. So then I could break that up again, but be careful with that minus sign out front. So I'm going to put minus a big bracket right now. And I'm going to say log 5 of x minus 1 plus log 5 of x plus 1, because multiplication breaks up as addition. And you could leave it like that, but I'm trying to get us towards something else in a minute here. So I would write it, to get rid of that bracket, you could just distribute this negative sign. So you could write it as minus log base 5 of x minus 1 minus log base 5 of x plus 1. That would be expanded completely. So then the other thing we want to do is go back the other way. And again, I have some basic ones and then a more complicated one here. But again, if we want to write it back together, that means every time we see addition, we could put it back as multiplication. Every time we see subtraction, we could put it back as division. And when we see a number in front, we could put it back as an exponent. And that's what you're going to want to do first. So when I see this 2 in front, and some of you are going to be able to do this all at once, and that's okay. I'm going to do it in a few steps on this one, okay? So if I see a number here, the first thing I'm going to do is put it back as the exponent. So that would be u squared minus log 3 of v. And then if I see subtraction, the point is to write logarithm one time here. I can put that back as division. So I can write that as log 3 of u squared divided by v. So you should only have log written once when you're putting it back together. So then I kind of went crazy on this one. Step 1, I'm going to put this 8 back in as the exponent. So I'm going to say log base 2 of the square root of 3x minus 2 all to the 8th power. And I'll just rewrite the rest of this. And since they're all log base 2, I want to put it all back together. Some people see that log base 2 of 4 at the end, that you could actually evaluate that and maybe break up the middle one. We could do that too if you want. so there's kind of more than one answer that we could get here, but I'm going to go with just putting it all back together, and then maybe in class, or if you could try this, see if you could get a different way of doing this. So when I see this, I just want to simplify it before I start doing anything else, though. The square root, remember that that's the same as 3x minus 2 to the 1/2 power. And then I'm taking that to the 8th power, or maybe you just know if you take the square root to the 8th power what you're going to get there. That's going to simplify down to log base 2 of 3x minus 2. 1/2 times 8 is 4. So that you don't need to write the square root to the 8th power. So I'm definitely going to do that. I should have made this more complicated and made that division worked out, but I did not. So now I'm just going to put it back together. So what do I have? I have subtraction. So log base 2 of 3x minus 2 to the 4th divided by 4 over x. And then I have addition, right? The last one we did subtraction. This is addition, so that means times just 4. And again, that's because it's to the log base 2 part. I do not want you to leave your answer like that. So I'm going to put this 4 up here. If it's just multiplied, think about that's just like 4 over 1. So I'm just going to say 4 times 3x minus 2 to the 4th. And instead of dividing by 4 over x, I'm going to multiply by the reciprocal, which is x over 4. Right? So like this is my division, multiply by the reciprocal. And so now I could cross these 4's out. And I think the best answer here is, well, where do you want to put the x? I'll put it in front. X times 3x minus 2 to the 4th. So today it's trying to just get comfortable with these properties of putting them together and breaking them apart so that we can solve equations. I think that's it. I could be wrong. Oh, wait, one more thing. I was wrong. So last thing here is the change of base formula. And maybe you remember this from last year, but the change of base formula is how if your calculator only does log, common log, and ln, which is base e, you can use the change of base formula to change any logarithm so you can evaluate it on your calculator, which is why we have a no calculator part of this test. So basically, you just take any logarithm of base a and you rewrite it with the base on the bottom to whatever base you want to change it to, and then the log of that base of x on the top. So this first one is kind of silly because why would you change it to any base? It makes sense to change it to base 10, which is common log, or base e, which is ln. So if I had this logarithm of base a, I could change it to common log by just taking the log of the base on the bottom. So I could do log of a, and then the log of x on the top. Or I like ln's, you get the same answer. So if I want to do it with ln's, again, the base goes on the bottom. So I have ln of a on the bottom, ln of x on the top. And I always remember the base goes on the bottom. And then that helps me remember where to put it. So this is just definitely calculator stuff. But log base 5 of 89, I don't know what that is, right? It's not a perfect power. I couldn't do it without a calculator. I could estimate 5 to what equals 89, but I could change it and read the directions. It says change to common log, so I could change that to log of 89 divided by log of 5, and this is where you need to practice typing this in your calculator. So make sure you put parentheses around the 89 or it's going to give you the wrong answer. And on my calculators, it automatically starts a parenthesis right here. Oh, I dropped my pen. And then you close it. And then on the bottom, it doesn't matter if you don't close it, but I just am. And if I round to 3 decimal places, I get 2.789, which is a really cool thing if you remember this from last year. Notice 7 and 8 says use natural log. Same rule, though. So this is just going to become ln of 18 divided by ln of 5. This one's going to be ln of e divided by ln of pi. And you can plug that in your calculator. But remember, ln of e is 1, so you could just plug this in your calculator. So ln of 18 divided by ln of 5, and that is 1.796. And if I do 1 divided by ln of pi, I get 0.874. And again, I hope that you practice these as you watch this video, because knowing how to use a calculator is a big part of this chapter. So here's your homework. And again, pre-label your paper so that you can get started as soon as you can. Or if you have specific questions as you're watching this video, please write them down or write them to the side so that you can ask me those before you get started on your homework.